Okay, so we are going to, whoops, wrong one, answer the following. Volunteers for a disaster relief effort were classified according to both speciality, C being construction, E being education, and M being medicine, and language ability. S, they speak a single language fluently. T, they speak two or more languages fluently. The results are shown in the two-way classification table. A volunteer is selected at random, meaning that each one has an equal chance of being chosen. We want to find the probability that, first of all, his specialty is medicine and he speaks two or more languages. Second, either his specialty is medicine or he speaks two or more languages. Third, his specialty is something other than medicine. Okay, so first thing we want to do is get totals. So you'll notice I've put an extra row and an extra column in here. So I want to total up each of the rows. And you notice I'm just going straight across. Okay, and then I also want to total up each of the columns. So let's see, 16 and 6, 22. And 4 and 2, 6. And then I want to make a total of this row. If I make a total of the row, it's 28. And I should be able to check because the total of this column should also be 28. And let's notice that it is. Okay, so let's start with number 1. We want to find the probability that we've chosen someone whose specialty is medicine and he speaks two or more languages. Now, that means there are people who specialty is medicine, but also know two or more languages. And let's notice if we look at the medicine people and the ones that know two or more language, that's 2 people out of 28. So 2 out of 28, or we can reduce that to 1 out of 14. All right, now this one we're going to consider both possibilities. Either their specialty is medicine or they speak two or more languages. Okay, now notice that or. So let's use our union formula. And oops, let me make some room here. We want the probability that they do medicine or speak two or more language. Looks like mud. Probability of M minus the probability of T, plus the probability of T, minus the probability of the intersection. Let's see if I can bring out that intersection symbol again. And we can think of intersection as both, probability of both. Okay, so the probability that someone has a specialty of medicine, well, let's notice there's 8 people total with a specialty of medicine out of the 28. The probability that someone speaks 2 languages or more, well, there are 6 people who speak 2 languages or more, 6 out of 28. And the probability that they are both a person who does medicine and they speak 2 or more languages. Well, we found that right up here. Now, I'm going to use the 2 out of 28 just to keep my denominators the same and make this an easier calculation. So 8 plus 6 is 14, minus the 2 is 12 out of 28, which is going to reduce to 3 over 7. All right, now lastly, we want to find the probability that his specialty is something other than medicine. So really, we want to consider the people who are construction or what was E, education. Okay, so if we look at those 2 columns, or those 2 rows rather, there are 13 people in construction and 7 in education. That's 20 people who are not in medicine. So that's 20 over 28. And again, we can reduce that. 4 goes into both the top and the bottom. So that will give us 5 out of 7.